Geoestima, Season 2, Chapter 1. Hi, I am Orlando Rojas, Chief Geology Consultant at Geoestima. Today, we are starting a new season of the Geoestima podcast. This season will focus more on specific work within the mining process, from sampling to reconciliations. For this reason, in today's chapter, we will start by talking about the sampling process, particularly its basic concepts, to continue discussing and learning more about the geo-mining-metallurgical business in Chile and the world. The sampling process, generally for any study, is obtaining and selecting samples from a representative subset of a larger population. This is done to obtain observations or measurements to infer or extrapolate results to a total population. This stage is fundamental for research, especially in geoscience. Before delving into what sampling in geology entails, it is essential to clarify some basic concepts of sampling. Let's start with population, the complete set of elements or individuals that share a common characteristics and are the subject of study. The sample is the representative subset of the population selected for observations or measurements. Simple random sampling is the method in which each population element has an equal probability of being selected to be part of the sample. On the other hand, stratified sampling is when the population is divided into groups and a specific quantity of sample is randomly selected within each group. There is also cluster sampling, where groups or clusters from the total population are chosen instead of selecting individual samples. Then, elements within these clusters are selected. The sample size is the number of elements selected for the sample. An adequate size is essential for obtaining reliable and representative results. While a sample is considered representative when its characteristics accurately mimic those of the general population, representativeness is essential for generalizing the results of the sample to the total population. Finally, sampling error is the discrepancy between the results obtained from the sample and those that would have been obtained if the entire population had been studied. The error can be reduced by increasing the sample size. Why is representativeness important in sampling? The main goal of sampling is to obtain applicable and generalizable results to the entire population. For this reason, a representative sample is essential for making valid inferences about the total population. Second, if a sample is not representative, its conclusions may not be valid for the population, leading to misinterpretations and incorrect decisions based on the data. Good representativeness increases confidence in the collected data, which will accurately reflect the characteristics and variability of the population. If the study results are applied to practical decisions, good representativeness will aid in applying the results and efficiently using resources. Additionally, it helps reduce bias in scientific sampling, which refers to the systematic addition of errors in sample selection. Minimizing or controlling bias in sampling is crucial to ensure the validity and generalization of results. Some common types of bias include sampling bias, which occurs when the selected sample favors certain groups and excludes others. There is also the bias of excluding relevant variables, which occurs when essential variables are excluded during the study design. Additionally, there is confirmation bias, which is the tendency to seek and interpret information to confirm pre-existing beliefs. In summary, the representativeness of sampling is essential to ensure the validity, reliability, and applicability of research results. allowing these results to be confidently used in decision making. Common errors. Samples are necessary for every mining flow and must be accurate and precise. Poor sampling translates to random noise reflected in the nugget effects of variograms. In sampling, there is a concept called fundamental error, which refers to the inherent or natural uncertainties of the materials being sampled. This error cannot be reduced but understood through heterogeneity tests, which provide a sampling monogram to evaluate the errors associated with our sampling processes. As mentioned earlier, fundamental errors cannot be avoided but can be mitigated with a suitable sampling protocol. Materials with higher fundamental errors will require more rigorous sampling protocols regarding sampling density and sample size than those with lower fundamental errors. The other most common errors are related to the sampling process, which is induced by the procedures we use and how we carry them out. These errors are delimitation, extraction, segregation, and contamination errors. These errors could have been avoided if sampling had been perfect. Still, they always exist and generate inherent uncertainties and limitations associated with the sample collection process and the representation of geological variability. Delimitation, extraction, segregation, and grouping errors can produce noise and bias. While fundamental errors produce noise, other possible errors include contamination, preparation, analytical, and weighting errors. Let's look at each error separately. First, delimitation error. This consists of the incorrect choice of sample shape when all material fragments do not have the same probability of being sampled. Next is the extraction error, which occurs when the sample shape is correct, but not all the material from the corresponding volume is extracted. The third is segregation error, when there is incorrect separation of different components within a selected sample. This error occurs everywhere: conveyor belts, silos, containers, mineral stockpiles, etc. It can be minimized by decreasing fundamental error, that is, the sampling protocol for a given sample weight take as many increments as possible and homogenize the sample before subsampling, but the latter is difficult to achieve. The fourth error we will mention is a fundamental error. Assuming all other errors are insignificant, the fundamental error is the minimum when the subsampling a sample by taking a large quantity. This error is managed, as we said, with the use of a sampling nomogram. In this chapter, we have just made a general review of what sampling is and the basic concept related to it, such as representativeness and bias. In the next one, we will continue talking about sampling, but this time we will focus on geology. We invite you to stay tuned for our next chapter, where we will continue discussing and learning more about the geomining metallurgical business in Chile and the world.